Hi, I'm Steve Moshier from Wheaton College, and I'd like to thank the organizers of this session for inviting me to present geological evidence for an ancient creation in 25 minutes. I understand that this session in part was motivated by the publication of this book that Steve has mentioned, which is a critique of flood geology as applied to the Grand Canyon, and I hope that you will all consider reading it. Our publisher, Kriegel, has a special deal for you, and make sure you get one of these time cards. Everybody have a time card? The difference between the ancient and recent creation views is dramatically illustrated in these two representative timelines. The recent creation timeline, and get this, is 2.3 million times shorter than the ancient creation timeline. This timeline does not follow from observation of the natural world. It is imposed by a particular interpretation of Scripture. It requires multiple routine supernatural interventions. This is the scientific biblical creationist paradigm. This timeline follows from the Genesis 1 sequence literally that the sun and the moon were made after the earth. It makes no difference that we now have images of other stars and other solar systems forming in our galaxy in much the same way as revealed by evidence from the planets, meteorites, and sun in our own solar system. And the only geoscientists who belong to this movement of biblical literalists insist that the 15,000 plus feet of sedimentary rocks in the Colorado Plateau were deposited in 1 year during the Genesis flood. The ancient creation timeline follows directly from observation of the natural world. Cosmic history is revealed by observations of the universe using the entire electromagnetic spectrum with bigger and bigger telescopes, some of them in space, and sophisticated experiments at the subatomic level in supercolliders. Geologic history is revealed by field studies of ancient rocks that compare to the products of ongoing geological activity. And the best part is, the event sequence is calibrated and quantified by radiometric and other methods. This is the actualist or uniformitarian paradigm. Most Christians in the sciences are actualists. Christian actualists celebrate God's direct action in creation because natural processes do not occur apart from God's creative will. The rock and cosmic records are studied independently of particular biblical interpretations, avoiding the practice of reading modern scientific meaning out of Scripture or defaulting to supernatural interventions. Why? Because scientific and biblical interpretations are subject to falsification. And with that, I will attempt to defend the ancient creation view with the following evidence. Geologic time quantified from radiometric dates, plate tectonic motions and mountain building throughout Earth's history, thick sequences of cyclically bedded sedimentary rocks deposited in shallow water, and examples of glaciation and rock erosion, supposedly mid-flood. Let's start with geologic time. Again, do you all have your geologic time scales? You can look on. The sequence of eons, eras, and periods was established by field relationships using basic stratigraphic principles by the end of the 19th century. Ages that calibrate the time scale are determined by radiometric methods since the 20th century and continuing to the present time. Flood geologists reluctantly accept that these dates mean something. The concordance of radiometric dates to the established sequence of rocks is beyond coincidental. The explanation by young Earth creationists is that decay rates that determine how fast radioactive isotopes change to non-radioactive isotopes must have been faster in the past. Russell Humphreys calculated that decay rates would have had to have been some 750,000 times faster for a 6,000-year-old rock to exhibit parent-daughter isotope ratios corresponding to some 4.5 billion years of decay. He proposes that there were two episodes of accelerated decay during the creation week and then again during the flood. Since the flood, the decay rates are very low and stable. But this scenario is impossible. First, there's a massive heat problem. This is a satellite image of Earth today, some 4,000 years after the flood. The crust is largely molten because 750,000 times the rate of radioactive decay would have melted the crust. And with that heat would have been toxic levels of radiation, probably even widespread nuclear fusion reactions in the crust. But we also have some empirical evidence. We get the same dates measured for minerals using different methods, which is essentially what Steve showed in the evidence from the Grand Canyon. I would argue that if you're talking about a 1,004,000-year-old rock, that's pretty good concordance between different methods. And the argon method, we would expect to be younger because of the argon loss of a gas phase. This chart shows that 4 different methods, based on 4 different decay series for a very old rock, yield essentially the same age. This would be impossible if all of the rates changed since the rock formed. There would be 4 different dates. Here are 6 ages for some of the oldest material in the solar system: meteorites from asteroids, moon rocks, a Mars rock, and the oldest Earth mineral and rock. They are all older than 3.5 billion years. They all would have formed during the first 3 days of the creation week when decay rates were faster. But there was no flood on the asteroids, the moon, or Mars. Shouldn't they be younger than the Earth rocks? That second episode of accelerated decay should not have affected them. The lower images here, corresponding with the table, represent 3 more igneous rocks from the creation week. They range from 1 to nearly 3 billion years old. Why are they not all the same age as the oldest Earth and rock and mineral if they all formed within days of one another, maybe even hours of one another? The upper images represent igneous rocks that would have been formed during the flood year. They range from 100 million to 424 million years old. Why are they not all the same age? True, the granites at Acadia National Park would have formed early in the flood year and the Yosemite granites late in the flood year. With the accelerated decay rates, the Acadia granites might appear to be some 300 million years older than the Yosemite granite. But all this ignores the fact that these granites formed from the crystallization of very large igneous bodies of molten rock that would have required more than a year to cool. Cooling rates are constrained by physical laws. In fact, one would expect these large igneous intrusions to require hundreds of thousands to a few million years to cool. Finally, all of these ages in this slide are from materials that formed after the flood. They range from 49 million years for Devil's Tower to about 3,000 years for charcoal recovered from an ancient Egyptian fort. According to Humphrey's hypotheses, all of these materials should have formed during the recent episode of slow radioactive decay. So why aren't all of these materials about the same age as the Egyptian charcoal? The simpler and more reasonable answer is that all of these 18 examples I've shared with you are really as old as the calculated ages. Now let's look at plate tectonics. Both ancient and recent creationists agree that the outermost brittle layer of the Earth, the lithosphere, is broken up into separate plates that move around on the upper mantle. The lithospheric plates are made of both ocean and continental crust. Ocean crust forms at mid-ocean ridges, there in the center, and spread outward, pushing around blobs of thicker, more buoyant continental crust. Ocean lithosphere can be pushed back down, subduct into the mantle where plates collide. When continents collide, they just grind to a halt and form mountain belts. Both ancient and recent creationists agree that in the past there have been supercontinents formed when all of the major continental masses collided together. Here's an exhibit from the Creation Museum. The flood geology explanation is that Noah lived on the older supercontinent Rodinia. Rodinia broke apart as the flood began. Continents moved apart and collided together to form Pangaea, the second supercontinent. Late in the flood, Pangaea broke apart, and the continents moved to their present location before emerging from the retreating floodwater. To do this in 1 year, they estimate plates were moving tens of feet per second. That seems to me that they have a testable hypothesis here. What would Pangaea look like if it formed this way? What would sediment deposits on Pangaea look like? After all, the Grand Canyon strata that Steve talked about would have been deposited on these sprinting continents. We know how fast the plates are moving today because we can measure it with sensitive GPS stations. There happens to be a station right here in Providence. We're moving at a rate of 1.6 centimeters per year away from the mid-Atlantic ridge. But were we really moving faster during the flood? The answer is in the ocean crust. We have a detailed picture of the age of ocean lithosphere from 50 years of deep-sea drilling. The inset map shows hundreds of locations where cores were taken from the ocean floor. The stripe pattern on the larger globe was discovered by mapping the magnetic properties of the seafloor, and the ages are from radiometric dates from the cores. Ocean crust is younger than continental crust because continental crust can't be recycled like ocean crust. The age of the ocean crust increases away from mid-ocean ridges. In the North Atlantic, the age ranges from 0 along the mid-ocean ridge, the red in the center there, to about 180 million years at the edge of the North American continental shelf. We can use Google Earth to determine the distance from the mid-ocean ridge to the shelf, about 3,000 kilometers. And doing the distance over time calculation, we determine that over those 180 million years, the seafloor was spreading at a rate of 1.66 centimeters per year. That's how fast we're moving now. Geologists predicted how fast we were moving in Rhode Island before the invention of GPS. Evidence on the seafloor is not consistent with continental sprint. So, did Pangaea form in 2 months or 600 million years? These maps show the progressive movement of continents bottom to top, leading to the final assembly of Pangaea. The Appalachian Mountains have preserved a record of sedimentation, igneous intrusions, volcanic eruptions, and rock deformation resulting from the formation of Pangaea. Some of the granite ages presented earlier in this talk help us to work out the timeline of the various collisions. One might expect very different rock structures in the Appalachian Mountains if they were created by the collision of continents draped with thick deposits of wet sediment versus continental margins of hard cemented rocks. It turns out that the bottom illustration looks correct. The deformation of eastern North America is evident in the landforms and bedrock beneath the coastal plain all the way to the Appalachian Plateau. Great broad slabs of hard granite, metamorphic, and sedimentary rock were shoved westward, one on top of the other, as Africa and Europe crunched into North America over a long period of time. In this cross-section, based on field mapping and deep geophysical surveys, we can see rift faults that were created as Rodinia broke apart in the Precambrian, the thrust sheets from the Pangaea collisions in the Paleozoic, and rift faults from when Pangaea broke apart in the Mesozoic. Here's a more detailed structural cross-section across the Valley and Ridge province of Southwest Virginia. The arrows indicate equivalent rock units of Middle Cambrian to Middle Ordovician age. It shows the multiple and systematic repetition of the units in the fault sheets. There's no evidence that the sheets moved along the faults at catastrophic plate tectonic velocities. Now let's look at the rocks under the star in Pulaski County in the lower cross-section below the word synclinorium. And those are shown in the bottom picture of the Conococheague limestone. Note that the limestone bedrock is tilted to almost vertical, so they surely have been deformed. Also note that these rocks were deposited at about the same time as the earliest Paleozoic sedimentary rocks in the Grand Canyon. Steve identifies these, as you heard, as early flood deposits, as water rapidly swept over the Great Unconformity. In the Grand Canyon, Cambrian rocks are hundreds of feet thick. In the Appalachian region, they are thousands of feet thick. What we see in the Conococheague Formation are cyclically bedded limestones that were deposited in shallow seawater. As seawater rose across the continents during the Paleozoic, there were short-term rises and falls of a few meters. When the water was a few meters deep, conditions permitted the growth of patch reefs composed of calcareous algae. When the sea level fell a few meters, the reefs were covered by tidal flat sand and mud. Mud cracks are evidence of drying in the sun above normal high tide. In southwest Virginia, there are over 400 of these shallowing upward cycles stacked up over 5,250 feet, just in this unit. The time estimate for this accumulation is some 26 million years. These conditions existed along eastern North America on and off throughout all the way through the Devonian period. Here are photos from Ordovician age cycles in eastern New York State and photos of comparable sedimentary environments in the Bahamas. Sandy deposits below the tidal range in the lower image. We see actual tidal creek in the ancient rocks that compares with tidal creeks in the Bahamas, and unequivocal mud cracks of the tidal zones. And these mud cracks in the upper left actually have vertical animal burrows in them, which is exactly what you see in a modern tidal flat, as you see in the upper right. This is a paleogeographic map of eastern North America. It looked like this throughout the Upper Cambrian to the Upper Ordovician. Collisions are starting to occur as Europe and island arc chains converge on the east coast where the limestone cycles were being deposited. We have evidence of the volcanic rocks now metamorphosed. They're buried beneath the mid-Atlantic states and actually here under New England. But the volcanoes produced super eruptions greater than Krakatoa in 1883. The ash from these eruptions spread high into the atmosphere and settled on the shallow seafloor as far west as Tennessee and Iowa, and as far east as Scandinavia. Remember, Europe and North America were closer together at that time. And note the dates from the minerals in the ash, perfectly consistent with the geological timescale for the Ordovician. How could these thin layers of ash survive the turbulent conditions of a global flood? They were deposited in rather calm, shallow water. Now let's compare the Cambrian map with a similar setting on modern Earth. All of the light blue shallow sea around northern Australia and Indonesia is actually continental crust covered by thick accumulations of sand, lime, and mud. This region could undergo compression in the future and possibly collision, creating a new mountain belt that might look like the Himalayas or the Appalachians. Let's stay in the southern hemisphere and look at deposits in Tasmania, which is just south of Australia, here rotated on its side for this reconstruction of Pangaea in the upper left. Remember, in the flood timeline, Pangaea is underwater, and I might add, Steve didn't mention it, but the feeling is that the water was very warm during the flood. In fact, these glacial deposits that we see are on all the continents of the southern hemisphere. This is evidence that Pangaea stretched across the southern polar region and great ice sheets formed. These deposits, called diamictites, can be compared to deposits from the more recent ice age and modern glaciers. The rock in the center even has striations, which are diagnostic scratches from transport by ice. Now let's look at examples of long-duration rock exposure and erosion. This is a photograph, again, of the Great Unconformity in the Grand Canyon. It's an undisputed erosional surface between the older Precambrian Proterozoic bedrock and the younger Paleozoic sedimentary strata. It would have been the surface over which the great flood waters initially scoured and covered, as Steve mentioned. An exhibit at the Ark Encounter proposes a testable hypothesis for the overlying flood layers. If millions of years pass between these layers being laid down, as suggested on the left, then erosional features would be present. On the other hand, if the layers were deposited quickly during the year of the flood, then rapid or no erosional features would be seen. I don't see how there could be any clearer or more obvious evidence of long-term exposure and erosion than in two levels of the strata in the Grand Canyon. First, in the lower part, we see channels were cut into the top of the Tonto Group and filled with sediment containing Devonian fossils. The entire Ordovician and Silurian systems are missing in the Grand Canyon. Second, after the Mississippian Redwall Formation was deposited, you can see a channel cut into the upper red wall. It was exposed long enough for these channels to erode and for caves to form. And those caves are filled with sediment from the overlying formation. There are at least 15 unconformable contacts in the Grand Canyon with clear evidence for long-duration exposure. And this is in the Proterozoic as well as the Paleozoic strata. Finally, there are many strata around the world preserving fossil soils. Depending on the bedrock material and climate, soils form at different rates. Mature soils exhibit distinctive horizons that are familiar to geologists and farmers alike. Mature soil profiles take time to develop, hundreds to thousands of years. The Badlands in South Dakota are distinguished by brown and red layers with sharp upper contacts. Maybe some of you have seen them. These layers are identified as mature soils. There are 87 of them in 470 feet of what would be post-flood deposits. Did these soils all form over a period of a few hundred years or hundreds of thousands of years? Some conclusions. The timeline of creation history is quantified by astronomical observations and radiometric methods. Plate tectonic motion has been uniform over Earth's history. Appalachian deformation occurred over hundreds of millions of years with modern rates of plate motion, not catastrophic plate tectonics. Cyclical sedimentary strata could not have formed in a flood year, time frame, or under catastrophic conditions. And strata contain abundant evidence of terrestrial deposition and long-duration exposure and erosion. In the upper left is a photo of my hometown, St. Charles, Illinois. It's a real place. You can see a show at the Arcata Theater. The present buildings are built upon top of older foundations. Future archaeologists might try to figure out what we did there. In the lower right is a movie set. It's not real, and it will never reveal a real history. It might even mislead future archaeologists who are not careful. I think the majority of geoscientists are working in the real world, the one that is presented to them and the one that I believe was created by God for us to study. Sadly, I think the young Earth creationist movement presents a movie set world to the church and to the public. One that is built out of misapplied scientific ideas and an earnest but unnecessary interpretation of the Bible. I believe the good earth has a glorious history. Thank you.